Hello students, I am Dilip Udani, Assistant Professor at LJ Institute of Engineering and Technology. In Fourier series, today's topic is Fourier series of even and odd functions. So in this lecture, I will teach you how to find out the Fourier series of an even function along with the basic concepts of even and odd functions. So let's start. So first of all, we will see what is an even and odd function. A function f of x is said to be even if f of minus x equals to f of x, and odd if f of minus x that is equals to minus f of x for all x. If f of x is an even function, then integration from minus L to L f of x dx that is equals to 2 times integration from 0 to L f of x dx. And if f of x is an odd function, then integration from minus L to L f of x dx equals to 0. We know that the Fourier series of function f of x in the interval minus L to L is given by f of x equals to a0 by 2 plus sigma n is from 1 to infinite an cos n pi x by L plus sigma n is from 1 to infinite bn sin n pi x by L, where a0 equals to 1 upon L integration from minus L to L f of x dx. An equals to 1 upon L integration from minus L to L f of x cos n pi x by L dx. And Bn that is equals to 1 upon L integration from minus L to L f of x sin n pi x by L dx. Whenever you have been given the interval minus L to L, you have to check whether the given function is an even function or odd function. And then after you have to find out the Fourier series of function of x. So based on even and odd function, we have different cases. Case number 1, when f of x is an even function, then we know that integration from minus L to L f of x dx that is equals to 2 times integration from 0 to L f of x dx. As you know, a0 equals to 1 upon L integration from minus L to L f of x dx. But here we are considering that f of x is an even function. So applying this concept, we have a0 equals to 2 by L integration from 0 to L f of x dx. Now similarly, we will think about an, and as you know, the product of two even functions, the result is even. So an that will be 2 by L integration from 0 to L f of x cos n pi x by L dx, because we are considering here f of x is an even function and cos is also an even function. So even into even function, the result is an even function. So integration from minus L to L f of x cos n pi x by L dx, it will become 2 times integration from 0 to L f of x cos n pi x by L dx, and this L will be as it is. So this is the formula of an. Since the product of an even function and odd function, the result is an odd function. So we have Bn equals to 0. Why it is 0? Because Bn equals to 1 upon L integration from minus L to L f of x sin n pi x by L dx. And here we are considering that f of x is an even function and sin is an odd function, right? So the product of an even function and odd function, the result is an odd function. So integration from minus L to L f of x sine n pi x by L dx, it will become 0. So we have Bn equals to 0. So whenever you have been given function of x is an even function, you have to find out only a0 and an, and Bn will be 0. Now we will see case number 2. When f of x is an odd function, the integration from minus L to L f of x dx equals to 0. Right? Now as you know the formula of a0, that is 1 upon L integration from minus L to L f of x dx. Right? And here we are considering that f of x is an odd function, so definitely it will become 0. So we have a0 equals to 0. Now since the product of an odd function and an even function, the result is an odd function. Now you know the formula of an, that is 1 upon L integration from minus L to L f of x cos n pi x by L dx. Here we are considering f of x is an odd function and cos is an even function. So the product of an odd function and even function, the result is an odd function. So its integration will become 0. So we have an equals to 0. Since the product of two odd functions, the result is even, and we have Bn, that is equals to 1 upon L integration from minus L to L f of x sine n pi x by L dx. Here we are considering f of x is an odd function and sine n pi x by L, that is again an odd function. So odd into odd, the result is even. So we have Bn equals to 2 by L integration from 0 to L f of x sine n pi x by L dx. So whenever you have been given function of x which is an odd function, then in that case a0 and an will become 0 and you have to find out only Bn. If the function is neither even nor odd, then we will have to find out a0, an and Bn. So whenever you have been given interval from minus L to L, you have to check whether the given function is an even function or odd function. If the given function is an even function, then you have to find out a0 and and Bn will be 0. And whenever the f of x is an odd function, a0 and an will be 0 and you have to find out Bn only. And if the function is neither even nor odd, then you have to find out all the three, that is a0, an and Bn. Now we will see one example related to this topic. Find the Fourier series of the function f of x given by f of x equals to 1 plus 2x upon pi when minus pi less than or equals to x less than 0 and f of x equals to 1 minus 2x upon pi when 0 less than x less than or equals to pi. Hence reduce at pi square by 8, that is equals to 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square and so on. Now here the interval is from minus pi to pi. So first of all we will check whether f of x is an even function or odd function. So to check whether the given function is an even function or odd function, we will replace x by minus x. So replacing x by minus x, so f of minus x equals to 1 plus 2 will be as it is, replacing x by minus x and divided by pi. And again we have to replace x by minus x over here, so it is minus pi less than or equals to minus x less than 0. So this is equals to 1 minus 2x upon pi and it will become 0 less than x less than or equals to pi, because we have multiplied this inequality by minus sign. And as you can see that 1 minus 2x upon pi, 0 less than x less than or equals to pi, that is nothing but the same f of x. So here we are getting f of minus x equals to f of x. Now again we will check for this function also. replacing x by minus x in this function. So f of minus x equals to 1 minus 2 will be as it is, replacing x by minus x divided by pi, and again we have to replace x by minus x over here also. So it is 1 plus 2x over pi. Now multiplying this inequality by minus sign, so we have minus pi less than or equals to x and less than 0. So we are getting the same function again over here, right? So here we are getting f of minus x equals to f of x. So we can say that f of x is an even function. So if f of x is an even function, then in that case we have to find out a0 and an only, and bn will be 0. So we have bn equals to 0. Now comparing minus pi to pi with minus L to L, we will get L equals to pi. The Fourier series of an even function with period 2L is given by f of x equals to a0 by 2 plus sigma n is from 1 to infinite an cos n pi x by L, because the value of bn is 0. Now a0 by 2 will be as it is, plus sigma n is from 1 to infinite an replacing L by pi, so we have cos nx, because pi will cancel out. Now we will find out a0 equals to 2 upon L integration from 0 to L f of x dx. Now in this expression we will replace L by pi, so it is 2 upon pi integration from 0 to pi, and in the interval 0 to pi we have f of x equals to 1 minus 2x over pi, and dx will be as it is. Now we will integrate this function with respect to x. Integration of 1 is x, then after minus 2 upon pi will be as it is, and integration of x is x square by 2, and this 2 by pi will be as it is. Now you can see that 2 by pi will be as it is, integration of 1 with respect to x, that is x, minus 2 by pi is a constant value, integration of x is x square by 2 according to the formula integration of x raised to n dx, that is equal to x raised to n plus 1 upon n plus 1. Now this 2 and 2 will cancel out. So a0 equals to 2 upon pi x minus x square by pi, and the limit is from 0 to pi. So 2 by pi will be as it is. Now replacing x by pi, so pi minus pi square by pi, it is minus pi, and the full lower limit 0, both the term will become 0. Now pi minus pi is 0, and if you will multiply 0 by 2 by pi, the result is 0. So the value of a0, that is equal to 0. Now we will find out an, and the form of an is 2 upon L integration from 0 to L f of x cos n pi x by L dx. Now in this expression we will replace L by pi, so we have an equals to 2 by pi integration from 0 to pi, and in the interval 0 to pi we have f of x equals to 1 minus 2x by pi cos n pi x divided by L is pi, so pi will cancel out, so we have cos nx dx. Now we will find out the integration of these two functions using Bernoulli's formula. So an equals to 2 by pi, that is a constant value. Now the first term 1 minus 2x by pi will be as it is. Now we will find out derivative of this function. Derivative of 1 is 0. Then after minus 2 by pi is a constant value, and derivative of x is 1. So the result is minus 2 by pi. Right? This is the result. Then after we will integrate cos nx, and integration of cos nx, that is sin nx upon n. Now again we will integrate this function, and integration of sin nx is minus cos nx by n, but already we have n over here, so it will become n square, and we will keep alternate sign, plus and minus, and this is the limit, that is from 0 to pi. Now first of all we will put upper limit in this equation. So for first term sin n pi is 0, and for second term cos n pi is minus 1 raised to n. Now for lower limit sin 0 is 0 and cos 0 is 1, so we will be having terms only. So an equals to 2 upon pi, minus minus plus, plus minus minus, minus 2 divided by pi n square. Value of cos n pi is minus 1 raised to n. As you know that the value of cos n pi is minus 1 raised to n and sin n pi is 0. Then after for lower limit, minus minus plus, plus minus minus, but already for the lower limit we have minus sign outside, so minus minus plus, value of cos 0 is 1 and 2 divided by pi n square. Now simplifying this result, taking 2 by pi n square common and multiplying it by 2 by pi, so it is 4 over n square pi square, 1 minus minus 1 raised to n. So this is an. Okay. Now we will find out Fourier series, and Fourier series is f of x equals to a0 by 2 plus sigma n is from 1 to infinite a n cos n x. Now in this Fourier series we will put the value of a0 and a n, but as you know the value of a0 is 0, so the first term will be eliminated and we will put a n. So a n is this one, that is 4 over pi square sigma n is from 1 to infinite 1 minus minus 1 is to n upon n square and cos nx will be as it is. Now say this is equation number 1. This is the required Fourier series of given function. Now we have to deduce this result. So first of all we will find out the value of f of 0. So at x equals to 0, here you can see that the given function is not defined at x equals to 0, right? So x equals to 0 is a point of discontinuity. To find out the value at the point of discontinuity, we have to find out the average value of left limit and right limit at that point. So f of 0 equals to 1 upon 2 limit x tends to 0 negative f of x plus limit x tends to 0 positive f of x. So 1 upon 2 will be as it is, and for x less than 0 f of x, that is 1 plus 2x by pi, replacing x by 0, so it is 1 plus 0, so the value is 1. Then after this plus sign, and then after for x tends to 0 positive f of x, for x greater than 0, function of x is 1 minus 2x by pi and replacing x by 0, so it is 1 minus 0, so the result is 1. So 1 plus 1 is 2 and 2 by 2 answer is 1. So the value of f of 0 is 1. Putting x equals to 0 in equation number 1, so f of 0 that is equals to this 4 by pi square will be as it is. Now for n equals to 0, first term is 2 upon 1 square cosine of 0. Then after for n equals to 2, 1 minus minus 1 is to n will become 0. For n equals to 3, we have 2 upon 3 square cos 0. Then after for n equals to 4, 1 minus minus 1 is to n will become 0. And for n equals to 5, we have 2 over 5 square cos 0 and so on. Now we will simplify this result. F of 0 is 1, taking 2 common, so multiplying 4 by 2, so it is 8 upon pi square, 1 upon 1 square, plus 1 upon 3 square, plus 1 upon 5 square, and so on. Now applying the concept of cross multiplication, we have 1 over 1 square, plus 1 over 3 square, plus 1 over 5 square, and so on. That is equals to pi square by 8. This is the required result. So in this lecture we have discussed the basic concepts of even and odd functions and how to find out the Fourier series of an even and odd functions, and we have taken one example which was an even function, and we have gone through the Fourier series of an even function. Thank you for watching this video. I will see you in the next lecture.